Amazon didn't just update its server chip this year, it quietly dropped a processor that forces the entire industry to rethink what a cloud CPU should look like. On Thursday, the company unveiled Graviton 5, its densest and highest performance CPU to date. An extraordinary 192-core chip squeezed into a single socket. And the improvements are not subtle. Graviton 5 delivers 25% more performance than Gravitoner and comes with 5 times more L3 cache than the previous generation launched in 2023. This isn't a small step in Amazon's silicon roadmap. It's a direct challenge to the companies that once defined the data center CPU market. For years, Intel and AMD set the rhythm of server CPU innovation, and cloud providers adapted to whatever they shipped. But the launch of Graviton 5 sends a completely different message. Amazon is no longer waiting. The world's largest cloud provider is building the chips it needs on its own timeline. Depending on the workload, Graviton 5 delivers roughly 40 to 45% more performance per watt than Intel's top Xeon chips, a gap that isn't supposed to exist in a world where Intel once treated the data center like its home turf. Built on TSMC's 3-nanometer process, using ARM's newest Neovis V3 Poseidon cores, the chip packs 192 cores into a single socket, supported by a massive 192 MB shared L3 cache, faster memory channels, PCIe 6.0, and direct integration with AWS's custom Nitro networking engine. But the numbers alone don't tell the full story. What Amazon has truly done is change what cloud performance looks like, how latency behaves, and what cost efficiency means at hyperscale. And to understand why Graviton 5 matters, it helps to look at the last 7 years of Graviton's evolution. When Amazon introduced the first Graviton chips in 2018, very few believed ARM servers would matter for mainstream cloud workloads. But the economics changed quickly. Graviton was cheaper to operate, more power efficient, and highly effective for scale-out applications. And over the last 3 years, adoption has grown so rapidly that more than half of all new CPU capacity added to AWS comes from Graviton. That's an unprecedented shift in an industry once dominated entirely by Intel and, more recently, AMD. Graviton 5 accelerates that momentum dramatically. The chip replaces the dual-socket Graviton for design with a single-socket architecture, and that change is intentional. Graviton used 2 96-core CPUs connected by a NUMA fabric. While this delivered a total of 192 cores, it introduced something AWS could not ignore: latency inconsistencies. As AWS VP Dave Brown explained, if a core needed to access memory located on the other CPU, the request had to travel across the interconnect, absorb protocol overhead, and sometimes wait in queues. Under some workloads, this cross-socket trip could take up to 3 times longer than a local access. In cloud environments running millions of operations per second, that kind of penalty is devastating. Graviton 5 eliminates the problem entirely. By designing a huge unified die, AWS keeps all 192 cores and all 192 MB of L3 cache in one physical unit, dramatically reducing intercore communication time. Brown said this shift cuts intercore latency by roughly 1/3, creating a far more predictable performance environment for tasks like online gaming, high-performance databases, EDA simulations, and analytics engines. These workloads rely on fast, synchronized data sharing, and Graviton 5 delivers that with minimal internal friction. The caching system is equally important. Graviton 5 carries 5 times more L3 cache than Graviton 4 and gives each core 2.6x more cache individually. This means far fewer trips to DRAM, especially in memory-intensive applications where cache spills once created bottlenecks. The redesigned memory subsystem supports DDR5 7200 and will soon handle DDR5 8800, giving the system the bandwidth it needs to feed 192 cores continuously without stalling. The performance uplift from these architectural choices is clear. Amazon says the new M9G instances deliver 25% more compute performance than the Graviton 4-based M8G family. What makes this more impressive is that the older MHG instances used two processors, while the new M9G relies on one. AWS is delivering more performance with less complexity, less latency, and fewer coherence paths. Graviton 5 also pushes AWS into a direct competitive battle with AMD and Intel. AMD's top-end EPYC processors now reach 192 cores, and Intel caps out at 124 cores. But both companies rely heavily on chiplets, smaller dies linked through advanced fabrics. Amazon's approach is different, a single monolithic compute die that offers lower latency and more predictable cache behavior. It's not just a performance play, it's a consistency play. And consistency is something cloud workloads demand. And Amazon wants Graviton 5 to be the chip for everything. Ali Saidi, AWS Distinguished Engineer, said the compute nodes themselves still include two sockets, but the instances customers receive run on one. The reason is simple: versatility. AWS wants a CPU that can shift workloads throughout the day without sitting idle. Nafea Bishara, co-founder of Annapurna Labs, explained it clearly. The best way to get the lowest cost is to build a product that can serve everybody. Usage fluctuates. In the morning it might be HPC, in the evening it's Fortnite. That versatility is supported by the chip's I/O capabilities. Graviton 5 is the first server CPU to ship with PCIe 6.0, doubling the bandwidth of PCIe 5 and enabling Amazon to attach next-generation accelerators and high-speed NICs directly to the chip. This matters because AWS's AI push is accelerating quickly. Earlier in the week, Amazon unveiled the Trainium 3 Ultra servers, its most powerful AI system yet. The new rack uses a scale-up fabric similar to NVIDIA's NVL72 and delivers a 4.4x performance improvement over the previous Trainium generation. And for the first time, the entire Ultra server stack, CPU, accelerators, and networking is built entirely on Annapurna silicon, with no x86 CPU in the loop. Networking is another area where Graviton 5 takes a leap forward. For M9G instances, the CPU is paired with Nitro 6, AWS's latest smart NIC. Nitro 6 doubles network throughput to 100 Gbps, offloads virtualization and storage workloads, and introduces Nitro isolation, which aims to offer mathematical guarantees that customer workloads remain completely separated. As AWS expands to millions of cores across global infrastructure, this form of isolation becomes increasingly important. With Graviton 5, Amazon is also targeting real-world adoption across its broad customer base. The company revealed that 98% of its top EC2 customers already use Graviton instances. That list includes Adobe, Atlassian, SAP, Formula One, Siemens, Airbnb, Pinterest, Snowflake, Synopsys, and Epic Games. Even Apple publicly credited Graviton for delivering 40% performance improvements and 30% cost reductions in its cloud workloads. These numbers aren't marketing metrics. They're the result of massive-scale production deployments. At re:Invent, Amazon also highlighted a use case from Korea. 12 Labs, a leading video AI startup, presented how AWS's new S3 vector storage automatically indexes images across huge datasets. CEO Lee Jae-sung said their multimodal video foundation model, built to understand video, voice, and time, relies heavily on the performance and scalability AWS provides. This example showcases how compute, networking, and storage improvements across the AWS ecosystem all converge around Graviton as the central processing engine. The Graviton 5 rollout begins with M9G instances available in preview, but compute-optimized C9G and memory-optimized R9G variants will arrive in 2026. As with previous generations, Amazon uses the same chip for all three families, adjusting the memory capacity and memory per core ratios to match workload needs. Of course, Amazon is not alone in the custom CPU race. Competitors are moving fast. Microsoft recently announced Cobalt 200, its second-generation ARM CPU, also built on TSMC's 3nm technology. Cobalt includes 132 cores, each with a remarkably large 3 MB L2 cache, and a total of 192 MB shared L3 cache, placing it extremely close to Graviton 5 in cache structure. Microsoft also implemented a custom memory controller that offers default memory encryption and ARM's confidential compute architecture, which prevents workloads from touching hypervisor memory. Google has stepped in with Axion, a smaller but highly efficient ARM server chip, offering up to 72 Neoverse V2 cores, 576 GB of memory, and 100 Gbps networking. Axion targets high memory workloads rather than high core density, fitting neatly into Google's internal service requirements. Oracle, while not designing its own CPU, continues to operate one of the largest fleets of Ampere 1M processors, which also reach 192 cores. These chips appeal to customers demanding predictable performance at lower power budgets. Despite competition, AWS still controls the largest production deployment of ARM CPUs anywhere in the world, and its internal momentum is accelerating. The company recently reached an annual revenue run rate of $132 billion worldwide, and much of its compute growth is tied directly to Graviton's strong price-performance advantage. Amazon framed Graviton 5 not just as a faster chip, but as an answer to long-standing trade-offs in cloud computing. Traditional approaches often force trade-offs between speed and efficiency, AWS wrote. Graviton 5 delivers up to 25% better compute performance while maintaining leading energy efficiency. Customers want to run applications faster while reducing costs and meeting sustainability targets, and Graviton fits neatly into all three goals. Beyond compute improvements, Graviton 5 also provides 15 to 20% more network and storage bandwidth, giving each core faster access to both data and I/O pathways. For workloads that stream, shard, or replicate data at scale, these gains translate directly into reduced latency and higher throughput. Graviton 5 marks the point where Amazon's custom silicon program is no longer just an efficiency project. It's an outright competitive platform, one that reshapes how hyperscalers build infrastructure and how customers choose compute. As the C9G and R9G families launch next year, Graviton 5 will expand into even more demanding workloads. But even at launch, the message is clear. The future of cloud performance belongs to the companies that build their own chips. Amazon has made its move, and the rest of the industry is now forced to respond. So, do you think customers will choose Graviton because of the performance, or because Amazon is slowly making it the cheapest way to run the cloud? Share your take below. And if you want to stay ahead of what's coming next in AI and computing, subscribe to Evolving AI for the latest updates long before they hit the headlines.